In the N63B44TU2 engine, as in earlier N63 versions, oil pressure is generated by a vane-type oil pump with variable delivery control. Using pistons of different sizes improves the acoustic characteristics of the pump. The design includes two sets of plungers with angles of 3 times 53 degrees and 3 times 67 degrees. By rotating the control ring, the pump's volumetric flow rate can be adjusted, which directly influences the oil pressure. In the N63B44TU2 engine, the volumetric flow rate is regulated by modifying the pump's characteristic curve. The current oil pressure is measured by a sensor and transmitted to the digital motor electronics, DME. The DME calculates the required nominal oil pressure based on engine speed and fuel injection quantity, then generates a modulated pulse signal to control the characteristic curve adjustment mechanism. This method provides smooth oil pressure regulation by precisely controlling the position of the control ring, which overcomes the spring force and sets the pump's delivery rate. If characteristic curve regulation fails, the pump automatically switches to operating as a conventional fixed delivery vane pump. Characteristic curve regulation depends on engine speed and load. In training materials, it may be displayed as symbols on the tachometer or load indicators. In previous engine versions, the piston cooling nozzle was integrated into the control valve. In the N63B44TU2, adjusting the oil pump via the characteristic curve allows oil pressure to be minimized during warm-up. As a result, the control valve does not open the cooling nozzle during this stage, preventing premature cooling of the piston crown. This allows the piston to warm up more quickly, reduces fuel condensation on the cold piston surface, lowers particulate formation, and improves compliance with modern emission standards.